So we're going to spend one more day graphing linear inequalities, and tomorrow we're going to be moving into graphing systems of inequalities. But it's real important to understand this concept of just graphing one inequality before we try graphing two at the same time. So remember, we're going to graph these just like we had done before, using the slope-intercept form to graph. However, we've got to concern ourselves with line type and shading. So remember, solid line, we're going to end up using a solid line when we have an inequality that is equal to. So greater than or equal to, or less than or equal to. Because the solid line means that the possible solutions are also on that line, along with either being above or below. Dash line is when it does not equal, so it's either going to be a greater than or a less than. And then shading. Remember, shading works this way. If it's above the line, we use it's a positive y is greater than, because the values of y that are bigger are like 2, 3, 4, 5, the bigger numbers. And if we shade above, we will get to those bigger numbers, the higher numbers that are higher than the y term. So we could also have a greater than or equal to as well. Shading below, positive y needs to be less than, or less than or equal to. So again, it's always positive y less than or less than or equal to, because the values y that are smaller than the value that we started at. Now we shade left if we have no y term and it's just x's. So again, these only are for when there's no y term at all. You don't even see that y term. This is when we're going to either shade left or right. So it only works with a positive x that is less than or less than or equal to, because the values of x are smaller when they're off to the left. And when we shade right, well, then it's a positive x is greater than or equal to, because the values of x that are bigger are to the right. Well, let's take a look at these problems here. Well, here we typically start the y-intercept, but we don't see a number. Well, that's when you have to add 0. So we have to start at the 0 and then follow what the slope says. Well, the slope is 1 to 1. If you don't see the number out in front of x, that's what it is. So we just go up 1 over 1 each time. We could also go the other way, down to the left. Gets you on that same line. And then what type of line do we use? Well, it's an inequality that's not equal to. So that means it's a dashed line. So right along those dots, we'll draw that dashed line. And then from there, we can go ahead and shade. Well, this is a positive y is greater. Greater means above. So above, well, greater are like, here is the y value at 0. The greater values of y are this way. So we are going to shade in this direction, on this side of the line. So this is it, in this side. And what this means is all these points here, these points, no matter where they are in this side, these points will all make true solutions when we substitute them into that inequality. Let's take a look at the next one. This one, we have a y-intercept of positive 1. So we're going to start one space up and then follow what the slope says. It says negative 1 to 2. So that means down 1 and then 2 to the right. Down 1, 2 to the right. We can also go the other way, up 1, 2 to the left. Gets you on that same line, up 1, 2 to the left. And then from there we need to draw the line. So this is going to be a dashed line again because it does not equal. We still don't see that equal sign, that line underneath the inequality. So it's a dashed line, but again it's a positive y, but this time it's a less. Less means below. And so we're going to end up going below that line. So below means smaller y values are this way. These are the smaller y's. And so that's the direction that we're going to end up shading down in this region here. And so there we have it, our answer. So all these points that I'm shading in on this side of the line are true solutions that will make a true solution when you go ahead and plug them in. The numbers on the other side would not make true solutions, so that's why we don't shade there. Well, here's another type. We have, in this case, a different situation. We don't have y by itself, so I can't use this 1 as the y-intercept, negative 2 as the slope. They're not really, because y is not by itself. We have to first divide by negative 1, And then we get y is now greater than or equal to. Remember, you divided by negative. That inequality sign switches. And now we have a 2x and a minus 1. So now we're going to end up with starting down below the line, negative 1. And we follow what the slope says, up 2 over 1, up 2 over 1. Do that a few times, and we got our points. Well, we can also go the other way, down 2, left 1 gets you on that same line. And this time we do get to draw that solid line through the points because it equals. See, it equals here, so that means that it is a possible solution there. And so we can go ahead and use the idea of looking at that y term. It's a positive y is greater than, and greater means above. Well, which way are the bigger y values? Bigger y's are this way, so that's above. And so all the points on this side of the line are possible solutions. That's why we shade there. Well, one more to try. In this one, we have the same scenario. See, we have a minus sign in front of the y. And so we actually have a 2 as well. So we need to divide by negative 2, each of the terms there. So when we do that, now we've got y is less than or equal to. So switch the sign when we divide by a negative. Now what's this? Well, this is 1 over negative 2. So it doesn't matter where the negative sign goes, as long as it stays as a fraction. Negative 1 over 2, same as 1 over negative 2. Negative over a negative makes a positive, so we have a positive 2 left over. So we've got to start up at positive 2 and then follow the slope. Down to the right, down to the right, down to the right. We could also go the other way, up to the left, and we get on that same line. And so from there we'll draw that line, and it's a solid line through those points. And we go ahead and shade. Now this is a positive y is less than, and so less means below. So smaller y's. Smaller y's are this way, so that's the region that we'd shade. All the possible answers are on this side of the line, not above. Well, that's some examples of problems that you'll see on tonight's homework.